Okay, guys, I'm here to try and work out a problem. Let's see how well this works. Just let me know if you can't see or understand what's going on. So I will need an email from you if there is an issue. So I'm going to share the document, and we were wondering how to work question number 9 on this worksheet. So hopefully you will be able to see this. So how many grams of ice at negative 12.05 Celsius should be added to 125 grams of ethanol to cool it from this temperature to that? So I'm going to start with a data table. And so I want to know, so I have two things. I have water and I have ethanol. And the mass I have for water is my unknown. And the temperature initial for the water is going to be negative 12.05 degrees Celsius. Temperature final is going to be 13.50 degrees Celsius. And we know C sub P for water is 4.184 joules per gram. That's joules per gram degree Celsius. Ethanol, the mass for ethanol is 125.0 grams. Temperature initial of this is going to be 25.04 degrees Celsius. Temperature final is going to be 13.50 degrees Celsius. And C sub P for ethanol is up here. Oh, we're going to use this other value. So we're going to use this one and we're going to use this one. So I'm going to change that. So this is going to be 1.00 calorie per gram degree Celsius. This is 0.58 calories per gram degree Celsius. So I can calculate how much energy I need ethanol to lose. And then I can calculate how much mass I need here. But the thing for the ice is it's going to start down here. It's going to go up to 0. So it's going to start at negative 12.05. It's going to go to 0. Then it's going to change phase. And it's going to end up at 13.5. So I have 3 Q's here that I'm going to have to calculate. So this would only be what I have here. This C sub P would only apply to Q3. For Q1, I need to use the value for ice, which is 0.05. So this is for the liquid, and then C sub P for the solid. It's going to be 0.50, right? Yeah. Calories per gram degree Celsius. And then we need to do the phase change. So I'll use that for Q2 and then for Q1, and then for Q2, I'm going to need the heat of fusion for water, which would be this value here. So Q for ethanol, which is alcohol, is going to equal 125.0 grams times 0.58 calories per gram degree Celsius. And then the temperature change is going to be final, which is 13.50 minus 25 0.04, and I get a negative 11.54 degrees Celsius. So if I multiply those all together, I get negative 836.65 calories. That's how many calories I need to put in from the ice to the alcohol. So Q total for the water for the H2O portion is going to equal positive 836.65 calories. So you're going to end up with X in 3 places. And let me see if I can get a little room to work here. I need all these to not have numbers anymore. And let's get rid of that. Q total is going to equal Q1 plus Q2 plus Q3. So this is going to be 836.65 calories equals, for Q1, I have ice. So I'm going to use this value. I have X grams, and I have 0.50 calories per gram degrees Celsius, and my temperature change from negative 12.05 to 0 will be final minus initial, so it'll be a positive 12.05 degrees Celsius. That's Q1 plus Q2, and Q2 is going to also be X, but now I need the heat of fusion for ice, which I have quickly forgotten, 80.0 calories per gram. There's no temperature change here because we're doing a change of state, so that's Q2. And then plus X times the heat capacity for water as a liquid, and that's calories per gram degrees Celsius. And now I do have a temperature change because I'm going from 0 to 13.5, so final minus initial, that'll be a positive 13.50 degrees Celsius. So then you can probably do this math, but let me help you with it. 0.5 times 12.05 equals 6.025 times X plus 80.0X plus 13.50X. I'm going to add those together. Plus 80 plus 13.5 equals, I get 99.525X equals 836.65. So I'm going to divide both sides by 99.525. And X is going to equal 836.65 divided by 99.525 equals, I get X equals 8.406 grams. Looking back at the data in the problem, looks like I have 4 significant figures. So I need 4 in my answer. The next value here is a 4, so it's going to equal 8.40 6 grams H2O. Hopefully that's helpful. Let me know if you have any questions about that. I did not follow my units through, but each one of these would be calories per gram. This is in calories, so when I divided them out here, since this is calories, divide by calories per gram, my calories would cancel and I would come out in grams. So let me know if that helps. I'm going to save this and let me know. Bye.